Hi, everybody. Hope you are doing well at this moment. I thought it would be helpful maybe to kind of go through these notes again in a little bit more relaxed setting because we were kind of rushed in class. So anyway, we were talking about conditional probability and kind of summarizing some of the ideas that we've been picking up in the last couple of days. Conditional probability itself just refers to the probability or likelihood of one event being affected in some way by the probability or likelihood of another event. That's what conditional probability refers to. And you can always just, if it makes it sound more sensible to you, substitute the word likelihood for probability. They're pretty much interchangeable, and one has kind of a better feel to it for a lot of people. Anyway, so that's what conditional probability means. We've got this kind of mathy way of saying it: probability of A given B. So in other words, given that event B is happening, what's the probability of A happening from that? And this is how our book always writes it. I don't believe they use this notation here, but this is a very common notation, this A/B. And I kind of like it just because the /B is kind of like, as we'll see later on, this actually is a fraction. Well, all probability is a fraction, but what we're dividing by is the probability of B. So it's almost like this is for the fraction bar, vertical fraction bar here for B. But it's not true for A. Anyway, you'll see what I mean. It's an okay symbol. This is very explicit, so this is what we're going to be seeing mostly. We also talked about independent events, and that is a pretty big deal in probability, whether or not events are independent. So independent events are such that the probability of one event has zero effect on the probability of another event. There is no effect whatsoever between the probability of one and the probability of another event. Okay? And we have this test for probability using the conditional probability as a way to test for independence. If the probability of A given B is the same as the probability of A, then A and B are independent. In other words, if you calculate this and you get some number, and then you calculate this and you get that same number, that means A and B are independent. And kind of a nice conceptual way of thinking about this is that this conditional probability, right, means that, okay, given the probability of B happening, what's the probability of A? And what we're saying is that the probability of B had no effect on the probability of A, as if it didn't happen at all, or just P of A equals P of A. So when these two things are the same number, that means A and B are independent events. However, if they're not, if the P of A given B does not equal the probability of A, then that means what we do there is we say that there's an association between these two events. We do not say that they are dependent. We don't. That's a little bit too far to go to say A is dependent on B or B is dependent on A. We can't really say that. All we can say is that there is a probabilistic association between A and B. There is some effect that A has on B or that B has on A. Okay? Now, if two events are mutually exclusive, that means that they cannot happen at the same time. Or in terms of kind of a mathy way of saying that, the probability of A and B, which you might remember this is the intersection of A and B, is zero. There is no overlap. Remember when we did some Venn diagrams, that would mean that the overlapping region in the middle had no elements in it. All right, if that's the case, then these are mutually exclusive events. Okay, so the other thing that we talked about today in class was this thing called the multiplication rule for conditional probability. This is kind of a more complete definition of conditional probability, and it also gives us a really cool way to test whether A and B are independent events, as you'll see in just a second. So anyway, the multiplication rule for conditional probability looks like this. The probability of A given B is equal to the probability of A and B, that intersection of A and B, divided by the probability of B. And you can see now why this symbol right here with the A bar B thing kind of looks like, you know, a fraction bar turned on its side with B on the bottom. I don't know if it strikes you that way. It always strikes me that way, but it's not just A over B, so don't be confused. It is A and B divided by the probability of B. That's what A given B actually calculates to. Okay, so that's our multiplication rule right there in the box. Now, if you do just kind of a simple and kind of ordinary algebra maneuver on this equation, which might be to multiply both sides of the equation by the denominator of that fraction, which is p of b. What you would get from doing that is p of b times p a given b, this here, equals just p of a and b. In other words, the p of b, when I multiply the right side of this equation by p of b, it cancels out this probability down here, and you're just left with the probability of a and b. All right, so we have p of b times p of a given b equals p of a and b. All right, now that may not be very helpful the way it is. However, this is what's cool about this. We earlier defined independent events in terms of the conditional probability, this a given b equaling the probability of a. Okay, so since p of a given b equals p of a when a and b are independent, all right, so what we can do, if we substitute p of a for p of a given b, this is what we end up with. P of b times p of a equals p of a and b. Just substituting this part right here with p of a. Well, what this does is this is only going to be true then when a and b are independent events. All right, we can only substitute p of a for this conditional probability when a and b are independent. So we've got this actually rather simple way of testing whether or not a and b are independent events. You have to be able to calculate their intersection, and you have to be able to calculate each one individually. But when you can, and you get the same number on the left side as on the right side, that means that they are independent events. Okay? All right, well, I hope that helps. A little bit more relaxed tour through the notes here. So again, I hope you're doing well right now, and go do some math, all right? All right.